In this video, we're going to talk about latency. Latency in its most basic form is the amount of time it takes your computer to process audio. So, if you are singing into a microphone and you have your microphone plugged into an external audio interface and you want to monitor back, you want to listen back in headphones while you sing, latency is the amount of time it takes for your computer to convert that analog signal to a digital signal, process it, and then convert it back to an analog signal for you to listen to. As you can imagine, too much latency is bad. And since we're working with a computer, we can't avoid latency, but we can take some steps to drop it down to manageable levels. The first thing we'll do is go into Preferences, and on the Audio tab, we have a space dedicated to latency. The big player in the latency battle is the buffer size. The buffer size tells your computer, specifically your CPU, how much time you're giving it to process the audio. With my setup and my samples set to 512, its overall latency is 23.2 milliseconds. So if I were to sing into a microphone or play a guitar and I wanted to monitor that back in real time with my headphones, it's going to take 23 milliseconds for that audio to get back to me. As a keyboard player, I record both real devices, so maybe a synthesizer or a piano, and I also record using a MIDI controller with devices and plugins. Personally, I can tell there's a delay, there's latency at 10 milliseconds, and my goal is to drop the buffer size low enough so I cannot tell there's a gap between when I hit a note and when I hear it. And that's about, again, 10 milliseconds. So right now we have 512 samples as our buffer size. Now I want to drop that down to maybe 128. I'm going to type it in, hit enter, and it looks like we've come in under that 10 millisecond range. So now there's the flip side. The lower the buffer size, the faster and the harder your CPU has to work to process that audio. If your buffer size is too low, the audio will start clicking, popping, and even dropping out. So there's a fine line, there's a fine dance between figuring out how much latency you can have and how fast and how powerful your CPU is. Luckily, we have a built-in test that we can determine a good starting point for our buffer size. So down in the test area, I'm going to drop the tone volume all the way down and turn on the test tone. So as I increase the test volume, I can hear a pitch, and it's also simulating our CPU at 80%. So when I drop down my buffer size as low as it will go, hit apply, we've got some nasty pops and cracks, and it might even drop out. So what I want to do is increase this buffer size to maybe 64. And now we don't hear as many pops, clicks, and that might be a good place to start. What I do sometimes, if I'm recording something and I want the lowest latency possible, I will drop this down for recording purposes, and then when I come back to mix or add effects, I'll actually increase the buffer size because I'm not playing anymore. So I can give my CPU a little more wiggle room, a little more time to process that audio. If you are using the built-in input and output of your computer, and you can't drop that buffer size low enough to get rid of the latency effect, or alternatively, when you do drop it low enough to get rid of latency, there are pops and clicks, it is probably time to invest in an external audio interface. That external audio interface does many things. One of the big ones is that it takes a lot of the conversion strain off of your CPU. So your CPU can worry about maybe processing effects and processing the device itself rather than doing the conversion. That external audio interface will allow you to drop your buffer size, resulting in an overall lower latency. So now you should have your buffer size set and your overall latency under control. Thank you so much for joining me. We'll see you next time.